Got some lovely Crayola markers this morning. What I've been trying to do is come up with my own unique colors and just kind of imagine some different hues, if you will. But they turned out to be a pigment of my imagination. It's strange. But I have found a way to find much brighter colors. So you guys don't need to buy neon markers, okay? All you need to do is take a marker, neon orange, neon yellow, am I right? Because, okay, I feel like I made my mark today anyway. I started eating markers a few days ago, but then I died a little inside because all right, I gotta move this really quick. Felt like those are worth it for you. You don't want to eat markers either because you might catch the Crayola virus, which is going around right now. All right, new strategy. So we've dealt with undoing the chain rule. We've dealt with undoing the product rule. We've got all of our standard rules. And now we have to kind of deal with some of these quotients. Now, there are many quotients we can't deal with. So today we're not really undoing the quotient rule. We're just picking out one specific type of quotient that we're able to attack. In order to do that, we need a lot of algebra background. So we're going to start with something very fundamental from way back in the day. All right, how do we combine algebraic fractions? Well, we combine algebraic fractions the same way we would combine any normal fractions. Let's say we had a problem like this. Of course, nobody in this class would dare tell me that the answer to this is 5/7. If you think that, just smack to the left, smack to the right, rattle some sense back into you, but you can't do that, right? We need a common denominator. So I would multiply this by, if we're just keeping it very simple, let's just choose the other denominator. But I'd be multiplying by 1. I'd multiply by 1 on the left. I'd multiply by 1 on the right. And we'd have a common denominator of 12. And you do the same thing with algebra. I'd multiply this by x minus 3 over x minus 3, essentially 1. I'd multiply this by 2x minus 1 over 2x minus 1. And since this is calculus class, we're not going to distribute anything in the denominator. We know that gives us a common denominator. So I know now that this will be my denominator. I'm just going to distribute the top. So I end up with 5x minus 15 in my first fraction. My second fraction, my denominator is set up to be identical. That was the whole point. 2x minus 1. And I will distribute this to negative, so be very careful. Negative 4x plus 2. And now that I have a common denominator, I can combine these two fractions just like I would up there. And I get 5x minus 4x is x. Negative 15 plus 2 is negative 13. And there's my final answer. No need to distribute this. Save yourself the work. There we go. This is as simplified as you need to do it. But this algebra is going to come up today. We're going to have to be able to do this. So let's do this much quicker. So this is what I hope your average everyday calculus student can do. I already know I have to multiply this on the top and the bottom, this on the top and the bottom. So I already know my answer is going to have this as a denominator. And now just deal with the numerator. Here to here, I'm going to have a 9x minus 6. As I go here to here, there's a plus in the middle. I'm going to have a 6x plus 6 if I multiply this on top and the bottom. And now I have no problem at all if you just do this in your head. You don't even need to write that down because the algebra is going to be a means to doing the calculus. So we get 15x here and nothing else. I can see the 6's cancel. If you need to write down this step, please do it. It's not a race. I want you to understand. But many of you, I hope, can jump quickly to this without doing much writing. So what are we going to use this for? Well, let's look at a couple actual calculus examples here. So a couple things we already know how to antiderive, believe it or not. This looks very complicated, but I notice x to the second, x to the first. So the first thing I would encourage you to always try, is to try u sub. See if this actually works. See if I can make the denominator u, see if my du might actually match up. What do you know? It actually does. So we know how to antiderive this. This is actually a perfect match. So when I pull off my u substitution, there we go. And it's a very simple antiderivative. So we end up with the ln of u, which is right there. X squared minus x minus 6 plus c. If you see fractions, you shouldn't be thinking, hey, we should try this new strategy. You should be thinking u substitution first and foremost. Always use substitution. If that fails, then look elsewhere. So in the second example, I see a fraction plus a fraction. This can be intimidating for a lot of students, but let's split it up. So I have 3 over x plus 2 dx plus, and then I have this one separately, 2 over x minus 1 dx. And again, you might look at that and be a little bit confused if you weren't sure. I know the derivative of x is a number, so I could do a u substitution here and let this be u if you really wanted to, but the derivative of x plus 2 is just 1. It's not going to change anything. Since this is x to the first power, and there's no chain rules here, I can jump right to an ln. If you don't see that, then do the u substitution. This is very unnecessary. But if you don't see that you can jump right to an ln, then do this, and then you realize you need a 3. So 3 du equals 3 dx, and now it's a perfect match, and you'll end up with, this is very unnecessary, but you end up with 3, and you end up with 1 over u du, and hopefully you can see how if I just remove the 3, that's what I had to start with. This was all completely unnecessary. All right, either way, I end up with 3 ln of this denominator, x plus 2. And notice how we could have just jumped right to that in the first place. We didn't really need a u substitution here. So I'm going to do that in the second one. I'm not going to waffle around. I know this will just become my coefficient. And then I've got 1 over x to the first. That's an ln. X minus 1 plus c. And there's my antiderivative. Done and done. Now there are some properties to logarithms. There is a way we could simplify this and rewrite this, but we'll get to that later. So then finally what we end up with is an example like number 3. All right, now obviously that's a segue into a new strategy, but I want to try this first. Let's always try u sub to see if it fails. I can't pull off a u sub as it is right now, so I'm going to try u sub. In order to do that, I'm going to have to distribute the bottom. And what do I get down there? Well, I get 2x squared. I can already tell this is going to fail, can't I? The derivative of that, I can tell this is going to fail, but let's go through the motions, right? So we'll get minus 7x in the middle plus 3 dx. U has to be my denominator. And so then du is not going to match, and even worse, there's no way to make it match. Because certainly I could multiply by 1/4, and that would make this x, but then 1/4 of 7 is not 13. And if I tried to make the 7 into 13 by multiplying by 13/7, well then 13/7 times 4 is not going to give me 1. Either way, this fails. But we tried it first. You should always try it first. So what do we do instead? Well, we have to use a new technique. And our new technique is called partial fractions. What we use are something called partial fractions. We're going to have to split this thing up. What we're going to do is we're going to turn something like this into something like this. We're going to split this up into two separate fractions because two separate fractions are very easy to antiderive. I can just jump right to an ln. But a product causes me a huge, huge issue. So we're going to take that product and turn it into something like this. That is the goal of the partial fraction strategy. Now first and foremost, before we get into this, you should always check U sub first. Always. Discipline yourself to try it. Even if you just do it mentally in your head, like if this was you, then would this match up? Is there any way to make this work? Because it's going to be a lot less rigor. I'm not going to have to do as much if U sub works. So I end up with 2x minus 1. And can I make that happen by multiplying by something? 3 halves would give me 3, but then it would give me 3 halves here. Okay, no. So this is a fail, but I checked it. At least I went through the motions and checked it. So what do I need in order to do partial fractions? Well, a big indicator that you're doing partial fractions is that the denominator factors. This is usually a huge cue that you're doing partial fractions. Now there are examples when you wouldn't, but they get very complex. You don't have to deal with those in Calculus 1 or 2. However, I will show you what they look like, but we won't really have to antiderive very many of them. That's tomorrow. You guys can look forward to that partially. Okay, so this has to factor. If this doesn't factor, I won't be able to split it into two separate pieces. So I start by factoring my denominator, and I rewrite this. So I'm going to have 3x plus 11 over, this will be x minus 3 and x plus 2 dx. All that factoring you guys did in Algebra 1 and Algebra 2 just keeps coming back. And now what is our goal? We don't want this. We don't want a product. What we want to be able to do is we want to be able to rewrite this. I want to be able to rewrite this as two separate fractions. What I want is something over x minus 3 plus a different something over x plus 2. This is what we want. Now these values are unknown. Somehow these values would be equivalent to 3x plus 11. But we don't know what they are. So we're just going to give them an unknown. I'm going to call this A. I'm going to call this B. And I'm actually going to perform some algebra to solve for this. Most of this strategy requires nothing but algebra. The calculus will be one quick step and done. So what am I trying to do in this problem? I'm trying to make this equal to this. So that's exactly what I'm going to do. So over here, I'm going to do all of my algebra. So I need my original 3x plus 11 over, I think it's this side of the board that's not really cooperating, because I think when I work on the other side of the board it works just fine. Yesterday I switched markers. Maybe I should switch markers again. But I want this, the original problem, to be equivalent to what I'm trying to make happen. X minus 3. Got my 3. I really don't like that 3. Spend a half an hour in this video just fixing this stupid mistakes. 3 plus B, switching markers. B over x plus 2. So this is what I'm trying to do using algebra. So I need a common denominator. I want these fractions to be the same. I want to show that this is the same as this. So I'm going to multiply this guy by x minus 3 over x minus 3, which is just 1, so I don't have to do this to both sides. I'm going to multiply this guy by x plus 2 over x plus 2, and that will give me common denominator, common denominator, common denominator. So my new equation will be this thing. Just going to recopy this. By the way, most of this you guys will skip in your head once we've gone through this once. So x plus 2 equals, now we have a times x plus 2 all over our common denominator. Please don't cancel the x plus 2's. The whole point of doing this was so that we had a common denominator. Don't take yourself back to where you started. And now we've got b x minus 3 over, well, now we've got our common denominator here also. So I haven't done anything wrong. I'm trying to argue these are the same. I set them equal, and I multiplied by 1, multiplied by 1. Well, now every one of these terms is divided by the same thing. So if I had 1/5 x minus 3/5 equals 8/5. So you guys see how I could multiply both sides by 5 and all the fifths would cancel? So I'm going to multiply both sides of this equation by the denominator, by the denominator, by the denominator. So I'm actually going to multiply both sides by this. On the left, cancel, cancel. And I'm going to multiply on the right. Well, that's not really what I wanted, but there we go. And I'm multiplying this whole quantity by it. So cancel, cancel on both sides. And now what's my new equation? Well, it's pretty simple now. I've got 3x plus 11 equals a times x plus 2 plus b x minus 3. Well, now what do? Well, our goal is to solve for a and b. That's the whole point of this. We're trying to figure out what these two values are so I can change this into this. Why am I doing that? So that I have a really easy antiderivative. A couple separate ln derivatives rather than trying to piece this apart with a product rule of some kind. So I'm almost there. I've almost got my two pieces. What do I do now? Well, the great thing about this is that when we started this premise, our goal was to solve for a and b. Those were the unknown values. It actually doesn't matter what x is. It doesn't matter at all, because this equation is already true. I know this equation to be true. It's true for all values of x. If I plug in a 12, this would be true. If I plug in a 13, this would be true. Every value of x makes this true. The things we don't know that make this true are a and b. So what that does is it allows us to pick. We can choose any x value that we want. Ooh, well, that's good news for us, because there's a couple x values that would be really, really convenient choices. I'm thinking if we choose x equals -2, that's going to give us something very distinct. If I choose x equals -2, this entire piece cancels out. Ooh, looks like we can solve for b. All right, so I plug this in, and I'll end up with 3 times -2 plus 11 equals, this whole term cancels, and we're left with b times -2 minus 3. And this is very quick algebra to solve. -6 plus 11 will give us 5 equals, -2 minus 3 is -5b, and b equals -1. And since we can pick whatever we want, well, let's just choose x equals 3. So choose x equals 3. And what happens? Well, now this is going to disappear. I'm going to end up with 3 times 3 plus 11 equals a times 3 plus 2. 9, get 20 on the left, and I get 5a on the right, so it looks like a equals 4. And we're done? No, we haven't even done any calculus yet, but we found our a's and our b's. So now what can we do? Well, we can go back up and rewrite our integral. So now that I know what a and b actually are, 4 and negative 1, I can rewrite this again. So rewrite, oh, don't do it again. Okay. We're going to leave that on the board for now. Rewrite one more time. Now I know a is 4, b is negative 1. So I'm going to put a 4 in for a, plus, I'm going to keep it addition and throw a negative 1 right there, dx. And all of that algebra saved the day. Now we have to do our one step of calculus, but this is a really easy step of calculus because what we created for ourselves is a x expression to the first power with a number on top. Well, I know it's just going to end up being an ln every single time as long as that is the relationship. So we can finish this problem very quickly. I know this is an ln, this is an ln, so I end up with 4 ln of x minus 3 minus the ln of x plus 2. And of course, we don't want to forget that good old plus c. There is our antiderivative using partial fractions. Notice the calculus step in this took you about 12 seconds. The rest of it took a lot. Now, once you've done this once or twice, you can skip so much of this. I don't expect you to write out this step. Don't expect you to write out that step. Don't expect you to write out this step. Skip all of this. You guys are hopefully going to jump right to this, solve, and get your answers and go back and plug it in. 2 quick steps. All right, if you don't understand where this comes from, that's why we did it the long way. So that all of this makes sense algebraically. How did we get to this point? Well, here's how. We set these fractions equal, we found a common denominator, we canceled the denominators. Boom, we're at that step. If you know we're going to do that every single time, then just jump right to that step. So let's be a little bit faster. I threw in something we have to be careful with, but this one's already factored. So what do I want to jump to right away? Well, don't skip your setup step. Always rewrite this. I would strongly encourage you to never skip this step. Some of you still will challenge me on that one. You know, you knock yourselves out. But we are trying to rewrite this as something over my first factor plus something over my second factor. So this step is critical, so we know exactly where A and B go. I would never skip this step. But if you want a challenge accepted, then fine, you guys rock it. So what am I going to skip past? Well, I know I'm going to set this equal to this. I know I'm going to multiply this by 1 and this by 1. I know I'm going to cancel the denominator, so eventually what I'm going to get to is this numerator is going to need to equal this times the other denominator, a times 2 minus x, plus b times the other denominator, 1 plus x. You guys can jump right to that. If that doesn't make sense, go back and follow what we did here. A times the other denominator, b times the other denominator equals the numerator. That's always how it's going to work out 100% of the time. So let's not waste time writing out unnecessary algebra. And now what seems like logical choices? It seems to me if I choose x equals 2, that's going to help a lot. And if I choose x equals negative 1, that looks like the other winner. Let's plug them in. Plug in 2 here, this goes away. Plug in 2 here, I get 3. I'll divide by 3 and b is going to equal 4/3. Plugging in -1, this goes away. I end up with +3. 2 minus -1 is 3, and I get a equals the same thing. Fantastic. And so now I do a second rewrite step. If you guys want to skip this step, you probably could, but I still don't like to. You're going to find that we are not writing down much anymore. So my second rewrite, just going to throw these things in the top. 4/3 over 1 plus x, 4/3 over 2 minus x dx. And now I can see this is really simple. I'm going to get 4/3. This is to the first power, so I know this is an ln. And now I wrote careful here. Why did I write careful? Well, because 2 minus x has a derivative. The derivative of 2 minus x is not 1, it's -1. We don't want -1, we want it to be positive. So I have to leave a minus sign out front to cancel that. So there is a little mini chain to this. So we get 4/3, it'll be minus to negate the negative, and 2 minus x plus c. And that is it. There is our partial fraction. And you see, once you figure out what you're doing algebraically, you can do the algebra in 2 quick steps and then jump into your calculus. But sometimes these have chain rules. Imagine this factored into 2x plus 1. 2x has a derivative of 2. We would have to cancel that if we were anti-driving. So there are some places you have to be careful with partial fractions. All right, so hopefully this strategy makes sense. What I have here are 4 examples, and I'm going to go through the work, give you guys a moment to pause and try a few or try none of them, and then I will pause the video, come back, skip all of my meandering, and then I'll talk about what you should have done and the answers you should have gotten. All right, so 3, 2, 1, pause. All right, welcome back. Just finished up, so here we go. You'll notice that every single time I always try a u sub first, try a u and a du. It failed, so then I went into my partial fractions. This is all I need to see you write down. Your setup step, your single step of algebra, and then make your choices and solve for a and b. They'll always turn out to be an ln, unless something else happens, which we'll deal with another day. Notice here, this was 4 minus x. This had a chain rule inside of it. The derivative of the inside of this is not 1, it's -1, and we don't want that. So I brought a -1 out, which canceled this negative sign. That's why this is plus. Okay, and number 2, much easier one here. The algebra is very simple. Choose x is 3 and -3, and boom, boom, we solve. And then in number 3, if I scroll down a little bit, you'll notice I tried u sub again. It clearly fails. There's no way to make this 16. So I go into partial fractions. Off I go, off I go, off I go. And here's our answer. I want to show you guys this once for all my AP test takers out there. But this could be rewritten. And this is how it's rewritten algebraically. So if I was to rewrite this, don't worry about AP test. How could I rewrite this? Well, this could be reordered into 4 ln x minus 2 minus 2 ln x plus 3. And then keep in mind, algebraically, this says the same thing as this to the 4th. And now this minus 2, we're going to leave the minus, and I'm going to move the squared here. So I know what you're thinking, well, we don't need the absolute value if these are even powers. Well, you're right, but notationally we'll keep it the same. And now ln of the same base e, this could be written again as a quotient. The subtracted piece, the difference between these two, is the same thing as x minus 2 to the 4th over x plus 3 squared. So it could be rewritten like this, it could be rewritten like this. So the AP test can really douche it up and give you guys different versions of the answers. Don't worry about this stuff down here. All right, and in the last one, this is a monster of a partial fraction problem, but I jumped into my setup, A over B, did my algebra, not very nice values to choose from here, which makes your A and B answers not very nice values. I wanted to give you at least one example of a very unpleasant partial fraction problem, but it's just algebra. You're just multiplying by reciprocals, so don't be intimidated by the fractions. And then I throw them back in and notice right here, a half had to come out because the derivative of this is 2. We don't want the 2, so we have to cancel it. Little baby chain rule there. Same thing here, the derivative of this is -3. I don't want the -3, so little baby chain rule to cancel. That's why I have the half and the -1/3. Same reason why I had to pull a negative out here and make this a positive. So there's your final answer in number 4. Very messy, but you guys can do it. It's just fractions and reciprocals, nothing too complicated. All right, so this is due. The next time I see you guys, this will actually be due in person. I'm sorry to the A-Day people. I forgot to pass this actual worksheet out, so you guys will have to get it on Google Classroom and then do it the old-fashioned way in a notebook or something like that. Okay, so let me know if you guys have questions. I hope next time we see each other is in person. All right, take care.